Hello everybody, welcome into another lesson. So today we are going to talk about evaluating the composition of trig functions. So here you have sine of the arctangent of 4/3. Clearly this isn't going to be like the last lesson when we had the special angles that we've been dealing with from the unit circle. What you're going to have to do is set yourself up a right triangle to be able to solve this. So you have inside the arctangent of 4/3. This is asking you what's giving you a tangent of 4/3. So set yourself up a right triangle. So go ahead and do that. So we'll call angle theta. We'll have an angle theta where the tangent is 4/3. So 4/3. Now, we don't know this side, so we need to use good old Pythagorean theorem. So that means that 3 squared plus 4 squared would equal c squared, which means that c squared would equal 9 plus 16. So c squared equals 25. And since we're dealing with a length, we only consider the positive square root. So c would equal 5. So let's go ahead and put that 5 in for our hypotenuse of this right triangle now. So that arctangent of 4/3 could simplify into theta. So now you're just simply finding the sine of theta. So that's opposite over hypotenuse, so you would get 4/5. So the answer you should get for this would be 4/5. So we're going to find exact values here of non-special angle related composition of trig functions. I'm going to keep that right triangle up because we're going to do that the entire lesson. Alright, now we're going to take the secant of the arc sine of 3/5. So we're going to evaluate the secant of the arc sine of 3/5. So what angle would give you a sine of 3/5? So opposite over hypotenuse. Let's solve for side A. Again, good old Pythagorean theorem. So 5 squared equals a squared plus 3 squared, which means that 25 equals a squared plus 9. So a squared equals 16, which means that a equals 4. So let's go ahead and put that 4 in for where the a is. And of course the arc sine of 3/5 would just simply be theta. So this just turns into the secant of theta, which we know secant is hypotenuse over adjacent, which would just be 5/4. So the answer you should get for this would end up being 5/4. All right. The cosine of the arc sine of 24/25. So we need to find the cosine of the arc sine of 24/25. So what angle gives us a sine of 24/25? We're going to start there. Well, so we know the sine is 24/25. So let's go ahead and find side A. So that means that 25 squared equals a squared plus 24 squared. So we know 25 squared is 625. That's going to equal a squared plus whatever the heck 24 squared is. I'm not quite sure. I want to say 576, but I could be way off. I was right, it's 576. So now let's see, that means a squared is going to equal 625 minus 576. Well, that's just going to be 49, which means a equals 7. So that means a would be 7. Of course, that arc sine of 24/25 would just turn into theta, so we're reduced down to evaluating the cosine of theta, which the cosine would be 7/25. So the answer we should get for this would be positive 7/25. I have about 5 more. This isn't a super long lesson. Cosecant of the arctangent of negative 12/5. So we're going to evaluate the cosecant of the arctangent of negative 12/5. So what angle gives us a tangent of negative 12/5? So let's see, negative 12 over 5. So that means we need to find the hypotenuse side C. So C squared would equal that 5 squared plus the negative 12 squared, which means that C squared equals 25 plus 144. So C squared equals 169, which means C is going to equal 13. So now we know the length of the hypotenuse to be 13. All right. So of course the angle that produces a tangent of negative 12/5 is just simply theta. So we're reduced to the cosecant of theta, which is hypotenuse over opposite. That would give you negative 13/12. So you should get an answer of negative 13/12 for this problem. I got 4 more. Alright, let's see. Secant of the arctangent of negative 3/5. So we're going to do secant of the arctangent of negative 3/5. So what angle gives us a tangent of negative 3/5? Obviously theta, right? So the tangent, we have negative 3/5. Well, we don't know the hypotenuse, that's side C. So that means C squared equals the 5 squared plus that negative 3 squared, which means C squared equals 25 plus 9. So C squared equals 34, meaning that C is the hypotenuse equals the square root of 34. So the hypotenuse is going to be the square root of 34. Alright, so this would just turn into the secant of theta, which would then end up, of course, giving you the square root of 34 over 5. So your secant should end up then being the square root of 34 all over 5. Alright, the tangent of the arc sine of negative 3 over 4. So we're going to take the tangent of the arc sine of negative 3 over 4. So sine, of course, is opposite, so negative 3 over hypotenuse 4. So let's solve for side A. So that means 4 squared equals a squared plus that negative 3 squared. So that means 16 equals a squared plus 9. So a squared would equal 7, meaning that a equals the square root of 7. So we found side A to be the square root of 7. Alright, so now this is just going to turn into the tangent of theta, which would give us negative 3 over the square root of 7, but we got to rationalize the denominator, so let's do that, and what you should get in the end would end up being negative 3 times the square root of 7 all over 7. So the answer you should get is negative 3 times the square root of 7 all over 7. And I got 2 more. Sine of the arc cosine of negative 2/3. So we're going to find the sine of the arc cosine of negative 2/3. So the cosine, let's see, negative 2/3. So that means we need to solve for side B. So that means then 3 squared equals that negative 2 squared plus b squared. So 9 equals 4 plus b squared. So b squared equals 5, which means b would have to equal the square root of 5. So now we found the length of side B, and that's going to be the square root of 5. So now this is just going to turn into the sine of theta, which would end up being the square root of 5 over 3. So the answer we should get for this problem would be the square root of 5 all over 3. And I got just one more and we're done. Good one. Cotangent of the arctangent of 5/8. So we have the cotangent of the arctangent of 5/8. Well, of course then the tangent, so that's 5 and 8. Let's solve for c. So c squared would equal that 8 squared plus the 5 squared. which means c squared equals 64 plus 25. So c squared equals 89, meaning that c equals the square root of 89. So we found the length of the hypotenuse to be the square root of 89. Alright, which this would just turn into the cotangent of theta, which, as it turns out, we really didn't need to find the length of the hypotenuse. The cotangent would just turn into 8/5. So the answer you should get for this would just end up being 8/5. So that's it for this lesson. Next lesson, we are going to graph inverse trig functions. So I hope everyone has a great night. Take care.